Hello, greetings programs. Hope everybody is doing fantastic, and thanks for joining us for this Tea, Coffee, and Code Central Time Perks, as decided to call it. This is actually started by Stephen Ball. He was doing it in EU, and I was like, oh, I love this format. I want to do more of it. And so he's still doing it in the European time zone. I'm not sure what time zone that is, but you can find that as well. And I'm doing it now in Central Time Zone. And if you didn't catch the reference, Central Perk was the name of the coffee shop in the TV show Friends. So I'm sure that was unintentional on my part. So the idea for this is going to be an informal conversation with software developers, and you can see webcams here, and we're going to, each one of us will have a topic to share, and there will be a conversation about that. If you have questions for the presenter around their topic, feel free to put those in the question panel, and I will pass those questions on. So I'm gonna go through and introduce everybody real quick. First, we have Marco Cantu. He's the Delphi and Rad Studio product manager at Embarcadero, author of 20 plus Delphi books, a Delphi guru and conference speaker. I'm sure everybody knows who Marco is if you're on here. The next person we have is Anders Ohlsson, Senior Director of Proactive Performance at WideOrbit, and I'll have to ask you what that means in a minute here. Been a Delphi guy since Turbo Pascal 3, plays with Delphi and Microsoft SQL Server between meetings. Anders actually used to work for Embarcadero, and I now work here, and I used to work at WideOrbit, so it's kind of like we kind of swapped jobs in some sort of weird roundabout way. Ian Barker, prolific British-American software developer, designer, narrator, poet, and Embarcadero Delphi MVP. I need to see some of your poetry sometime, Ian. Born in London, but lives in Dallas, Texas, claims Delphi as his superpower. Unfortunately, he doesn't have any radioactive spiders, so he hasn't got any other superpowers yet, but eventually. Radioactive flies, maybe. Zack Briggs, Embarcadero MVP, works at Rapid Kinetics. Chief Development Officer there. He's the co-host of Delphi Mystics podcast, software and hardware engineering. You can see behind Zach, he's got a whole bunch of hardware stuff going on there. Great stuff. There's his email address, and he's active on the Delphi World Slack channel. Then let's see, Glenn Dufke, and I just got a message from him. He doesn't have the link, so I will get him on here in a second. He is a Danish-born software automation and electronic engineer. Delphi Wizard started in Delphi 7, now in 10.4.2. He's always doing interesting stuff. He's got something interesting going on, it seems like. So he uses lots of programming languages. He's a pragmatist, which I think is a good thing. We should all have lots of languages in our belt. Embarcadero MVP, enthusiastic advocate, and enjoys teaching modern Delphi Object Pascal programming languages. He's taught a few courses and such as well. His website's codekungfu.com, and enjoys pushing the limits of compilers, electronics, and tech. That's what I always like to push the edge of the envelope on things. And Dave Akerman, self-employed English software engineer working on PC applications for industrial automation and engineering applications, mainly in Delphi since version 6. I haven't seen Delphi 6 written VI, but I Roman numerals. He also does C and Python. His hobbies are flying weather balloons, designs the code, GPS radio trackers, desktop applications, web, mobile, etc. And actually, Dave, I will tell you, I was talking to Craig Chapman, and he mentioned you had worked on the project we'll talk about in a little bit, and he's like, oh, I know him. I didn't know he did Delphi. So anyway, small world. So then there's me. I'm Chief Developer Advocate Engineer for Embarcadero. I'll be moderating questions and getting Glenn a link so he can join. So with that, I'm going to turn it over to Marco, and Marco's going to kick us off talking about his new book that just got released.
Yeah, I want to take the opportunity, but feel free to ask any question even about around the product and other things. I want to share this thing here. Hey, it's physical, it's printed, looks good. It was a huge effort. I thought, just do a light review, and it ended up spending an inordinate amount of time on it. I'm quite happy with the result, but it was a lot of effort. So you can get the PDF from Embarcadero. It's free, so it's good for them. They paid me some money, so it's good for both. But also you can get the printed version if you want the physical thing. It's on Amazon, so it's like it is printed by Amazon technically, so that's why it's kind of the best thing to buy on the side. It might become available elsewhere, but that one gets printed locally, kind of locally. Locally in a number of countries, I think 10 or 15. So So that's it. I mean, it's been a good effort trying to put it together, just covering the new features, but also revising some of the core. And the last thing has been cleaning up the style, and also editing the language style guide that's going to be get public soon. And so I tried to make sure that the two things were in sync, which took me to find out that I had some mistakes in my
Mistakes in your styling in your book that you corrected with the style guide, is that what you're saying? Or
yeah, I found things in my book that were not aligned with the style guide, and in some cases the style guide was right and I was wrong. So I made a bunch of change in the formatting of the code, and I think I applied everything to GitHub. There might be a couple of things that are still not on the GitHub code, but they got in the printed book. I need to make sure I sync up. But there's the source code is available. I don't remember the number of pages, but it's 533 pages. So it's quite a tome. And I actually ended up reducing the margins because otherwise it was getting too big. I mean, not because of the extra cost of printing is really negligible, but because it gets heavy. It is already heavy. So the previous the formatting I had until some point was like 40 pages more, and then I added like a half an inch throughout the borders, and I gained like some 30 pages. So that was the final work.
so that's what I was going to ask, is if somebody has read the previous version, which I have on the bookshelf behind me, not that I've not read the whole thing. I've read a whole technical book in so long, but how much is going to be different or changed or new from the previous version, would you say?
I mean, in terms of brand new content, I mean, completely new is not much. I mean, just the new language features, but it's not like staggering. So maybe like 5% is really brand new. I mean, completely new. There are other things that are significantly rearranged and modified, like memory management because of the no-arc transition. So it's not exactly new code, but it's a slightly new perspective. But the other thing is that really gone through editing, re-editing and cleaning up and improving the entire thing. I had a lot of great feedback from a couple of people in the community, and then I paid a person to do full editorial work. So I don't think there is like a single paragraph without a change. And some of them are minor, like maybe a comma missing, some English thing, some are improvements in the description. But the other thing that I try to do, and I've not done it completely, honestly, is really to make sure that some of the change that are core to the language, for example, inline variables, are not just, the reason like in the last chapter, hey, now we have inline variables, but inline variables are presented in chapter 2 with variables and the lifetime of variables, and all of the options are there from the beginning. Now, I haven't updated all of the for loops to use an inline variable in it, but I try to do it. So I try to clean up some of the text, considering that there are new core elements like managed records or inline variables that are parts of the language. So it's kind of a spread. Changes are really spread out. Now, if you have the old one, you don't find like it's not a brand new book. But if you want to read one, reading this one is better because the text is more. It's a better picture of today's language compared to 3 years ago, 4 years ago.
And it is available as a free download. I just put the link in to download the free version.
You can ask for Embarcadero. You can get the PDF. Again, if you want to get it printed, it's good. I think I saw like 50 or so in the first 10 days, which is a good average.
Expect it'll pick up. I personally, I love having print, digital, both. I just do. I don't know about everybody else.
If I turn my camera, you can see. This is all Delphi books from the top to the bottom. So
I think I've said this
Marco
before.
is
I don't mind, but not only. There are better pictures on my Twitter feed. I said that because I put this new bookcase.
Marco is the living archive of Delphi books.
Yep. His Mastering Delphi 3 book was my first Pascal book, short of the Turbo Pascal one I stole from my brother's college texts. But yeah, I went through that. I had the pages laminated like the cover because it kept falling apart because I used it so much. And yeah, so that's why I tell Marco all the time that he was the author of my childhood.
I have a similar story. When I started programming with Delphi 7, I actually went to the library and picked up Mastering Delphi 7. And that was kind of like, that became my Bible to Delphi.
I called it the Tome of Power.
I don't think you had one for Pascal 3, right, Marco?
I have a few Pascal books in that chat, yeah, but not many. I mean, I used Turbo Pascal 3, but I don't think, I wasn't really buying books back then. It was too affordable.
I was rereading the Niklaus Wirth original paper the other day. And someone had linked to it. I'm like, do you know, I don't remember actually reading that. I read through it, and it's actually pretty clever. His arguments about why Pascal needed to exist was pretty impressive, and I think it's still true today. A lot of the time, you're saying, "Oh, there's better ways of making the language understandable," immediately, rather than trying to infer from what was going on, the functionality of it and stuff like that. And during his day, there were lots of very weird and esoteric languages, so I think it wasn't difficult to come up with something better.
Yeah, some of that's coming out because it's the 50th anniversary of Pascal this year. Yeah, there was a post, actually ACM hosted on an article on the 50th anniversary of Pascal. It's great, but I think it has a bias against any commercial Pascal implementation, which I find a bit. It does mention Borland and the early days kind of thing, but then it mentions all of the derivative Pascal from Modular 2, Modular 3, Oberon, and so forth, and completely ignores the fact that there's one commercial implementation with quite a bit, which is Delphi. But it's fine. I mean, it's from an academic perspective, so it is.
So you quite often hear people say, Delphi's not a language, it's a product. And I see the argument for that it's actually comes from a commercial organization. It's not a collective of people, but a kind of loosely organized open source group or something like that. But actually, if you look at Free Pascal and things like that, they talk about the Delphi variation, where you can turn on Delphi compatibility. And I think it's a language. I mean, I think Rad Studio is probably the product. But Delphi itself is a very specific direction that Object Pascal is going in.
You could argue the same with most other languages out there with a commercial backer. I mean,
haven't gone through this latest one. Is there any distinctions between, are you just focused on the Pascal language in it, pulling in any distinctions between VCL versus FMX?
No, there is a bit which I think I should expand a little on RTL, and specifically the intersection of RTL and language, like T-object or exception class, or things that are kind of, system.path. There is a chapter on system. Again, it could be argued, is T-object part of the language or the library? So there is that, and there is another chapter which is more purely RTL. So it introduces streaming, T-persistent. Again, a little too short. But no, it doesn't. By design, it doesn't go into UI libraries. It has demos that makes. Some demos are VCL, some demos are FireMonkey, some demos are just console. Honestly, mostly it's a button and a memo that displays something on screen, so in text. So it's not even the command line. Just for the sake.
It's focused on the core, on getting people up and running with the core.
Yes, it is. It is really only on the language. It doesn't, and it doesn't even go much into architecture side of things, like how you design a class library. It goes into the specifics. Make your data private. Of course, but not in terms of going to patterns or going into more. Or architect, how you structure your classes together. It's more, hey, this is how classes work. These are the features the language provides. From the beginning to the end, I think it's pretty complete. There might be some very, very corner, including some obscure one.
It's an interesting thing, though. I was thinking about this a while back about the line between the language and the libraries that you use in the language, and where does that line fall? Because like you're saying, is the RTL really kind of is part of the language. They certainly, you wouldn't, so people, occasionally someone was saying, oh, when is Delphi going to have a compiler for CUDA cores on GPUs? And I'm like, the language I can see maybe, but then if there's no libraries, is it really Delphi? So, it's an interesting thing to think about from that point of view.
My guess is what they really want is a neural networking library or something like that.
Well, the next step will be massively parallel PCs, where you won't just have one CPU with multiple cores. You'll have multiple CPUs with multiple cores, and probably some other kind of engine. Because at the moment the GPUs kind of being abused, to do processes that you could say. I mean, back in the day, I started in Unix, and back in those days, we had machines like the Sequence Symmetry, which was a very big fridge-sized box, had Unix universes in. So it ran multiple versions of Unix on the same machine. So it wasn't just like multi-user, it was multi-Unix. It was kind of bizarre machine. But they had lots of additional hardware that was designed to do very specific jobs, not just like a different network card, but a different routing chip and things like that. And I think the way we're going with GPUs and stuff, the way that it's being used for non-graphic computation, I can see that there is a market there at some point for some of these chip manufacturers to go, we've produced a chip here that is a multimedia chip, not just like a sound card, like in the old days where you had a sound card that you slotted into your rack or something like that, but something that's got very specific purposes. And I don't know what those will be. Maybe there'll be AI unit or some other combination of things, but I can definitely see that, and then it's going to get very challenging with Delphi, because that's when you start having to think, although it's event driven, the idea of parallel processes are going to become much more relevant, I think, because you'll be wanting to shuffle off some of these threads and things like that onto some of these bits of hardware. It's going to be some years to come, because people at the moment have stagnated because of the COVID-19. Things are not really, there's a lot of people sitting at home doing things, like baking bread that they've never made before, but I'm not so sure that that many companies are actually also using that time to do research rather than sell. Most of them are trying to just stay afloat. And I think
another thing, sorry, go ahead.
No, I carry on. I think that's where I was going, in saying that I think a lot of companies this year of COVID, I even have a t-shirt, I don't know whether it reads back to front, but it says, when this virus is over, there's still some of you that I want to stay away from me. But I think this whole year is stagnated. A lot of industries, maybe not for software developers, because some software developers have gone away and their side project has become a little bit more. Yes,
I keep trying automating myself out of a job, but it's impossible because there's always more and more stuff to automate. I've not come up with a way to automate the automation process yet.
Oh, it'll come.
Meta
Google will
automation.
do it. Yeah.
I think bridging the gap that Ian's talking about, though, is there's been a lot of push into like FPGAs. I think that those are going to be part of the thing that bridges the gap between the CPU and the GPU. You're going to end up with application specific tasks that I think will be routed off sometimes to FPGAs because it's more efficient than sending it to the GPU or sending it to massively parallel processing and computing clusters.
Do you remember the days of the 286 where you would have a separate floating point unit? Am I the only one? I mean, I'm pretty old, so I remember the 80s with fondness, instead of going, I was 6. No, I was pretty old and working already. And I remember those, floating points. And the thing that happened was we tried to scale down to get towards a point where we would have a portable computer and a laptop. It's worked. We all have mobile phones. I remember seeing the first iPod. Yeah, iPod with the operating system on it, and I knew, blown away by it. Like, this is a computer. It's handheld, it's got a touch screen, it's incredible. I knew then that this was going to be a big game changer for us. And I was a bit worried because I thought, if this isn't opened up to us being able to develop on these machines, then I'm going to have to find another job, a different industry. And okay, so I do a lot of weird things, poetry and audiobook narration and stuff like that. But even so, programming is the thing that since the age of 14 years old, that's all I ever wanted to do. The world is weird. Anyway, we were talking about Marco's book. And
and then finally, if we need to switch topic, I don't know if there are questions that popped up.
I bought your book, by the way, if that counts. It's a good book.
Neil's commented here, it says, I still remember Pascal MT with the great feature to implement procedures reacting to interrupt signals of the processor. I think that we are seeing a big expansion of infrastructure. I mean, it wasn't that long ago that multi-threading asynchronous programming was not a concern, but now everybody has multi-core systems. And I guess now I think about it more, it potentially could make sense to have the ability to be writing some code in Delphi and have that code execute on the GPU or execute on a remote machine, right? So it's a way to optimize something you're doing in some way to expand your functionality, so that you'd be running your applications running on the CPU, but it executes part of the code on the GPU in some regard.
There are some libraries that actually do it, but there are some very nice use cases beyond graphics, of course. Specific. There's some very specific use cases where things are useful, and you can get significant performance improvements on some of your processing, but it's not really general purpose in the way. It is important and it's coming, but the thing that's also important to remember is that, like, that's true even with multi-threading. I mean, multi-threading can really allow you to get way more power, but it's not free. I mean, it's not free in terms of the code you write and the care you need to put into making sure things don't overlap.
And the heartache when it crashes and you can't work out where the bug is.
Absolutely.
And you just
it might even be the CPU that's leaking. It may even be the CPU that's leaking some memory around to other processes. So it's an interesting word, but yeah, it's important. We push some extra effort to further clean up the parallel library because we think it's a relevant thing. But it's true that, I mean, you also need to make sure you compare in terms of, I mean, is pure computation the real bottleneck? For a few customers, I mean, for a few Delphi developers, it is, because, wow, they really need to do massive computation, but for the majority, it is not. So it's important to optimize the right thing.
Well, one thing I like about Delphi is it gives you the ability to kind of merge that together. Go ahead, Anders.
If you have a heavy application and you're only using one core on the machine, on my laptop, you'd be using 1/12 of the compute. So, I mean, in certain situations, and certainly in our case, we're massively parallel, both on the database side and the client side.
I think that one of the things to also consider about Delphi is it's commonly used with very specific, like, special purpose applications and like scientific computing and stuff like that, which may also be a big push of why they're going, hey, why can't we get a CUDA compiler or, you know, some sort of library related to that? Because if they're using it for biology or they're using it for physics or, you know, some of these things that we know it gets used for, might be of serious benefit for them. Computer vision, they're trying to get computers to be the ones to do the pathology reports now and analyze the samples. And so, I mean, that I could see where there might be a push.
All right, well, we need to move on. So actually, Zack is up next. Rising tide raises all boats. So Zack, talk to us about how to do business as a Delphi consultant.
Yeah, one of the things I started in on recently, I say recently, it's been going on probably for, I know Glenn and I have been talking about it for at least 6 months. Something that has been affecting the industry, software development industry in general. This isn't even necessarily specific to Delphi, but that is, how do you do the business with Delphi? I mean, I sometimes respond to posts, and, you know, I've kind of moved into more of an observational state recently. Somebody says, hey, Delphi is so expensive. And I'm thinking in my mind, okay, I understand why it feels costly, but from a business perspective, I've made the argument publicly that it costs less than a cup of coffee a day, or, you know, I've made all kinds of different arguments to that. And it got me thinking, okay, well, I know how I felt when I first started out trying to do consulting with Delphi. And that was, I made a mad dash to figure out, you know, how much can I charge? How much do I charge? You know, how do I roll my costs in with my actual operational costs in with my charges and my projects and stuff? How do I quote? There's all these question marks that I think everybody has. And so I started trying to go down the road of doing, I think we were calling them coffee talks at the time. It was before the TCoffeeAndCode thing came along. But it's been kind of slow progressing in that area. And so Jim and I were talking about it, and I decided I would talk about it here. We have people that are highly experienced in the industry on here right now. And everybody here has probably got a different thought process or has been involved at a different level in the industry. So some of the common questions that I've been asked is things like, how much do you charge? How did you come to that conclusion as to how much to charge? How do you quote your projects? How do you avoid, you know, customers feeling like they didn't get what they had asked for? You know, they asked you for a piece of fruit, you gave them an orange, but they wanted an apple. You know, how do you handle that? And then how does the cost of Delphi factor into your business? And another interesting one that rose up is, how does the cost of free things affect your business? Because I think I've said before, nothing costs me more than free things. And the reason that tends to come about is because there is a cost, even though it's free. So yeah, I mean, I think that my goal here would be to kind of get some information from all of you guys. You've all been in different places. So
number one thing about contracting is feature creep for a customer.
Scope creep.
It depends. Yeah, scope creep, feature creep, however you want to put it, because it depends on the sophistication of the customer that you're dealing with.
Mm-hmm.
But I tend to deal with people who are entrepreneurs, and they're slightly mercurial. That's what makes them successful at business, but that's what makes them bad at planning quite often, and bad at scoping what they want. And so, you know, they're not professional developers, but they know what they want their product to be. Mm-hmm. And so you're trying to say, when you say you want this product to do this, I understand you to mean the following. And they say yes, and you lay it out for them in a spec, and then you quote based on that spec. And then you deliver, you know, hopefully a number of different iterations to say, am I on the right track still? You know, I'm not making a mistake, am I? And this is my experience anyway. And all of a sudden they'll say, oh, but what about the Macintosh version? You're like, we said it was a Windows product. Oh no, it has to work on a Mac as well. Otherwise, this product's useless. But this is a completely different ethos. So I've used VCL, and now I'm going to have to work on it. It's the gotchas in the understanding of the customer that quite often is the problem, and the fact that you've not, between the two of you, communicated in a way where both sides are equally understanding what the task is. That for me is a recurring problem. Literally 3 hours before this meeting, I just had a session where I was showing someone, here's what you asked for, what I've done, and they're like, oh, it's brilliant, brilliant. By the way, I want that bit white. It's like, what? We agreed these screenshots. Now you want me to change these things, you know?
I think that that scope creep is definitely something that gets a lot of developers. I think we feel a kind of responsibility or guilt when we give birth to these products on behalf of the customer, and we go to hand it to them, and they're like, but I wanted it in beige. Okay, I'll just make that happen. And we start tumbling down that rabbit hole.
Early intervention and iteration. You know, I use mostly a kind of modified, I suppose, agile method, because it works. If you do iterations frequently enough, for once, that's not my dog's barking, that's good. But iterations often enough that people are understanding, they're joining you in the process of producing the product. You don't have to show them everything, like, here's this line of code. Do you think this is beautiful or what? You know, they're like, I don't know what you're talking about. But I think that, you know, when you're quoting for the job, if you quote for a fixed price, that's crazy for a start. But if you quote for a fixed price, then the last thing you want is them to change direction. So I think if you do it early enough, you can say, well, hang on, that wasn't what we agreed. You know, I want stage payments if we're going to keep moving the goalposts. It's difficult. It's a very difficult balancing act, which is why I prefer to work with long-term people. You know, my longest-term customer I've been working with 22 years. You know, we still disagree on many things to do with what's deliverable or not. But we always agree on the price, which is.
I think that we get lost in the weeds. Somebody had wrote in here, desire to please the customer makes some projects endless. I've got a few of those endless projects on the bench behind me. I've fallen into that trap myself. That happens. I think you're not doing the customer any justice, because from their perspective, this is continuing to go and go and go. It's not getting finished. They didn't budget for it. You're not doing them any favors. They may have already told customers, hey, it'll be done by, you know, June 30th. Or we have to get, I think as developers, we have to get, especially if you're an independent developer, not working under an organization, we have to get into the habit. This is the scope and this is the box we're working within. This is what's going to give you minimum viable product. And minimum viable product is not typically, I think Jim showed me a picture once. It's seldom, you know, a layer cake that's stacked like this. It's actually the edge of the pyramid kind of thing. And so we have to complete that and establish that that means this part is complete. Now we can quote the rest of, you know, these other things you want added to it. Do the things that provide the most relief to the customer up front, and then, you know, let's work on the the other things, the bells and whistles and the spinning rims and everything else, you know.
Ian mentioned fixed price versus non-fixed price. And the thing about fixed price, fixed price seems like a great idea, but the reality is I think it's probably more expensive realistically, because you have to do so much work to capture all the ideas and solidify it and then fix that. The reality is it's not going to be fixed. It's going to change. And so but the reality is that when you're doing a smaller sprint, you still have to say, this is what I'm working on in this sprint, right? This is what I'm going to deliver. And you have to define that to as much as possible and then create that. I know, for example, Marco does a lot with the PM work, as far as like defining what's features that are going to be in the next release and stuff like that. It's a lot of effort to define what it is we want to accomplish, right? And then get everybody on board with that.
Yeah, the thing you were saying, Zach, about defining scope and having a minimal viable product or a minimal viable release for the product. It's what, but the product is Delphis, not what we built with Delphis. But it's kind of the same story. I mean, it's still a piece of software that has requirement and has different things that come to define what we want to do and what we do. With a bit of complexity around it. It's not that exact.
So I just saw a question come across, and I think it's really actually kind of important to bring this up. Somebody asked, how often are you wrong with your predictions about how long your project will take and how much it should cost? I can tell you from a personal experience, all the time.
The biggest lie in the world is the project will be finished on the following date.
Yeah. I have spent the better part of the last 2 or 3 years trying to perfect an art regarding that, and it really is an art. I've come to the conclusion that it can't be a science. There's too much creativity involved with it, but that doesn't mean we can't get good at it. The answer to that question is all the time, in my case, to a frustrating and nauseating level. It frustrates managers that are involved. It frustrates clients. And our industry is just wrought with it. It's not specific to programming. This goes on in the IT management side of things. It goes on in network infrastructure projects. It goes on with everything. And you would think like network infrastructure, well, wow, that wouldn't be that big a deal. It's physical, tangible things where known quantities are being applied. Oh, trust me, it happens all the time over there.
Unless something is extremely simple, you won't finish it on time. My dad told me something 35 years ago when I was probably 15. He was working as an R&D manager for Siemens working on mobile phones in Pascal, by the way. And they were doing debugging on stacks of printer paper that there were no debuggers back then. So anyway, he taught me that, when you estimate a project, you estimate what you think it's going to cost and how long it's going to take, and then you multiply that by pi. He has not been wrong. It sounds like a joke. He's not been wrong. That's been my experience. I mean, it might be pi plus epsilon, but it's always going to take longer.
That's why there are so many methodologies out there for project management. There's so many qualifications for project managers.
Oh yeah.
And so many, like Agile exists entirely because everybody else up until that point was feeling the pain of, I thought it was going to take this long and it took 5 times as long or something like that. And still, Agile, I've worked in Agile companies and worked in companies that use a big, twice yearly waterfall method or something like that. And they both have pros and cons, but it's a recurring problem for everybody. Software estimation is always, it's never what you, and the more you measure it, the more you get it wrong as well.
Yeah.
Yep.
It's the same thing with your contractor that's going to build your retaining wall. Well, you know what? Guess if they ran into the water table a lot earlier than they thought, it's going to cost you a crap load more money.
Who did this before? This plumbing? Because whoever they did, they messed it up, and it's going to take me twice as long.
Yeah, exactly.
Mentioned that.
There's a book that I was reading called Software Estimation. It was actually, I think, prompted by Microsoft. I believe it was a Microsoft employee that put it out, Steve McConnell. The book, if I remember right, is like this thick. One of the very first concepts in that book is obviously you got to have clear scope. You have to have a clear definition, avoid scope creep. But projects, when you're estimating a project, an estimate is not a project plan. That's one of the mistakes people make. The two of those things are not related. The other thing is we have a tendency to go, okay, it's going to be this much, it's going to be delivered on this date and this time, instead of providing ourselves a range that we can try to get these features done in this amount of time, somewhere between these dates, between these numbers. And if we start to fail, here's what we have to have, here's what we'd like to have, which things can we drop off of here as we get closer if we run out of time. And see, I think that's a hard concept. I know in US culture, when it comes to quoting a business, they're expecting a piece of paper with a line item on it and a price, and then they're expecting a delivery date. And so this concept of you can't, an estimate is not a fixed point in time, but a range. We tend to try to go toward the 80% end of that range to make it accurate. But and that may work out in our favor because it may be under or it may be over. But at least if you're over, you're only over in that 20% area instead of in the lower end. So 80% of the time you're over, But yeah, the concept that it's a fixed point in time is not conducive to actual project management. But yeah, these are topics that we could talk about every single week because there is just so much information. And like I said, I've been reading just volumes and volumes of information, trying to become better at the art form. But I did see where somebody said, "Oh, I'm glad to hear it's not just me." No, it is not you. It is the bane of my existence.
There's a really good book called The Tyranny of Metrics, and Google it. And I would suggest reading this book because it talks about KPIs, that are used by a lot of industries and measuring things and how what systems are more successful than others in measuring. And there's a really good thing there where they talk about the Japanese. I don't know the word for it, but the underground trains in Japan, they point at things, like bizarre things, like they point at the sign, they point at the doors. And this came out of a number of crashes that were just based on simple mistakes. People drove off with some doors open because the safety mechanism didn't work. That came about because of the measuring system that they used to work out that there were these crashes and why they happened. There was also things like a medical system where they said they wanted so many people being treated in a certain period of time. And what happened was that the surgeons that were involved in that just changed the way that they calculated what was wrong with you. And so they categorized you in a different category and would put you out on a bed out in the corridor. And this is not something you can do with software. You can't suddenly say, well, when you said the project's finished and ready to sell, you didn't really say that it was ready to sell. You meant this. And the tyranny of metrics talks all about that kind of measuring and how difficult it is. And repeatedly in every single industry, it's about the more you try and apply a set of rules to it, the more you'll find that there are outliers that don't match those rules. But you've got to get it more reasonably correct if you're a contractor, because it's going to cost you money if you've agreed a fixed price. And if you're someone like Anders, where you're working in an organization where there's a lot of people involved in the development and a lot of I'm guessing there are quite a lot of fraught end users at the end of it who've got quite a lot of power to push back and give you pain, the customers. Yeah, exactly. So you've got to get it right for ulterior motives that are not always necessarily to do with the fact that you're embarrassed that you were late. It's about you might lose your customer or your job, or you might not get paid.
Exactly. Well, and Marco juggles this all the time because he juggles it from both sides. He's got to deal with the project cost and timing overruns and trying to avoid those.
Why wasn't my favorite bug fixed?
yeah, exactly. And then on the other side, he's dealing with a product that's already in the market that people are already using that have their own demands that are like, what do you mean you can't release 10.20 today?
And also an organization that has like salespeople that would like to have a release this quarter to push up sales a bit, and marketing that would need 2 months in advance when the date the new website goes live, and all sort of things which are legitimate. It's their role, but it is difficult. And then also again, there are directions and trends in the industry that make a lot of sense in general terms, like having a lot of velocity, having like frequent releases. But then, I mean, you end up fighting with the fact, yeah, you want to have it frequent releases, but you have like a juggernaut 50 gigabyte thing to ship, which is what we have, and it's making it slightly difficult to do frequent releases. We do daily builds, well, when the build doesn't fail, and yeah, but the build takes a good part of the day, so we can build in parallel to get it faster. You know, it's difficult to apply the same rules and concepts, but I have to say a lot of the internal developers and developers we work with are some of them are actually even quite good at providing estimates, I have to say. I don't know how to make it, but I'm quite impressed positively estimates that we get from some of the people we work with.
I'm gonna have to jet. I have to go get my my COVID vaccine. So hooray! I'll be able to go to the coffee shop soon.
Good for you.
But one thing I did want to do, shameless plug here. If you go to delphimystics.com/inbox, if you guys are interested in suggesting any topics related to the business of business with Delphi, and some of those things, like I said, I'm intending on bringing into here for our discussions, since I'm not able to dedicate the time needed to make it a completely separate thing. Anyway, if you go there, you can suggest additional topics and you can upvote things that you guys want to know about so that we know what's on your mind. Yeah, anyway, hey, I appreciate joining all you guys.
Thanks, Zach.
Thanks.
Thanks. Thank you.
So I will add a few comments here about estimation. There's a Hofstadter's law that says it always takes longer than you expect, even when you take Hofstadter's law into account.
Is that a Big Bang Theory reference?
Oh no, it's pretty Big Bang Theory. That's why I didn't think about that. But anyway, it isn't very helpful, I guess. But that's kind of just the thing that things do take time. All right, so next up we have Anders Ohlsson going to talk to us about WideOrbit. And now, what was your title again, Anders? It was a proactive.
Well, it's senior director of software engineering, but I've been doing proactive performance for a little over 2 years, 2.5 years maybe, and that's all about trying to find the bottlenecks in our software before the clients see it.
Okay.
So, you know, large scale testing, stress testing, load testing, all those kind of things.
We have to have a conversation just about that at some point. That's an interesting topic.
Yeah, there you go. Database monitoring products, for example, to see what's going on with wait states and stuff like that on SQL Server. We're a SQL Server, SQL Server shop for both W Traffic and W Network. Those are two biggest products in Delphi. We also have W Media Sales, which is in Delphi. There are probably anywhere from 20 to 50 million lines of Delphi code between them. You know, we have a client that's probably not 90 megs or something like that, and that's pretty thin, you know, in my mind for what it does, because it has thousands of forms and stuff like that. And then we have a back end or a middle tier, I should say, with probably anywhere from 12 to 20 different types of app servers specialized for different purposes, different integrations, that kind of stuff. I mean, so just a little bit about WideOrbit. We're the system of record for the broadcasters out there. So we've got, you know, 93% of US television, 50% of US radio, a lot of clients outside the US as well in international markets. We integrate with digital advertising platforms like it used to be Google DoubleClick, you know, it used to be called Dart for Publishers, now it's called Google Ad Manager, and a number of other digital integrations as well. So when you go to Facebook and Google or Twitter or Instagram or whatever, you know, your broadcasters may be running digital campaigns on those platforms as well that are trafficked through our software. And traffic, of course, refers to the trafficking departments at the broadcasters. They basically are in charge of, selling their commercial inventory. You have your breaks in radio and TV that you fill up with commercial content or ads, spots, that sort of thing. So those are all bought and sold and invoiced and all kinds of stuff like that in our software. Why do we use Delphi? Because it's simply the best at making software. In our case, for what we use it for. We're Windows, we're SQL Server. We tried and failed many other versions a long time ago, Visual Basic early on, that kind of thing. But it's been Delphi since 99, I believe. And we're running almost the latest version of Delphi right now. It obviously, with this many millions of codes, it takes a long time to port something and replace with a new Delphi version. You got to wait for the component libraries. We use probably easily 20, 30, 40 various third-party component libraries for Delphi as well. And yeah, are we hiring Delphi developers? From time to time. I haven't looked if we are hiring anybody right now. But from time to time.
Strategies about how to hire Delphi developers or things you found that work really well for that?
That's a great question. I mean, when I first started with WideOrbit almost 8 years ago or so ago now, 2013, I referred a number of Delphi developers to WideOrbit. They're still with us. We're lucky that we have such a great culture that we have very, very little attrition. So our developers stay with us for a long time, so which is really great. And obviously I was piggybacking on 18 years working at Embarcadero / Borland, but also and before that as a customer since Tour Pascal 3. So I had a lot of contacts. So that was how I helped out our hiring team today or back then. Good question. I mean, they use I know recruiters use, they use LinkedIn, they use Indeed, they use all kinds of different methodologies. I have not kept up on those in the last 2 or 3 years, probably.
Sounds like you have a lot of developers there, Delphi guys.
We got quite a few, yeah. I believe we're the largest U.S. non-government, non-military shop for Delphi.
Impressive.
Very cryptic, non-government, non-military.
Probably...
So that's what the drones run on.
Yeah, there might be a couple of others on par, but yeah, in the US.
Okay.
That's probably true.
That's
and I
good.
think a couple of bigger organizations outside of the US.
Yeah.
Yeah, there's a few in the UK as well, I think, but they're not as big as WideOrbit, I don't think.
There are plenty of worldwide companies that are bigger, have more developers than WideOrbit, I believe. But anyway, sorts of tools and components that we use. I mean, I could probably mention them all. We actually did a licensing survey project where we dug into with automated tools to figure out all the licensing stuff that we did. But DevExpress is one of the biggest ones. We love DevExpress. Great components. We used a grid. It's probably the most visual component in our products.
I was gonna say it's amazing. You get a component like a grid like DevExpress's grid in Delphi, and it's like so much functionality that just comes right there that you just have all of a sudden. It's like, I mean, that's like years of programming done out of the box. I love that.
Yeah. No, it's like we were talking about moving requirements and stuff like that. Internal projects and happens with that as well. So we've been toying around with a couple of different ways of visualizing data, performance metrics, not of humans, but of the databases in the field at the broadcaster locations. And we throw together some little visual tool. It's really easy to just drop down a DB grid or whatever, but then you want to filter and stuff like that. It's like, okay, rip that out and put in a DevExpress Grid. Done. Because now you can sort it. You can shift click on multiple columns, and you're sorting on, creating an index on the fly, 1, 2, 3, etc. Descending, ascending, whatever you want. It's very, very powerful, very flexible. We absolutely use VMs for development. Yes. I mean, it's almost a requirement, right? You have all these things that you need to deploy to your developers. 30, 40, 50 sets of components, for example. We can't tell everybody to install those every time there's an update. So, we refresh those dev VMs on regular basis and stuff like that, and everybody uses those. Well, most people use those, but yeah.
Do you have like a DevOps team or person that does like the VM prep, or how does that work?
We do have one person that typically does that work. So, I mean, if we're migrating to a new version of Delphi, for example, it's on a couple of people to make sure that it upgrades nicely, get all the components in there, and does all the code compile, does it run, does it pass all the automated tests, all that kind of stuff, right? So, yes.
Beyond DevExpress and virtual machines, you mentioned, as far as like the proactive stuff that you do, are there certain tools that maybe are just like key for you in knowing that you're getting the best performance possible?
So as we're very database heavy on SQL Server, so it was funny. I was reading a couple of threads where we were talking about people still using single core machines. I'm like, what? Is that even possible? Yes, in a VM scenario it is, but not in a physical hardware scenario. Minimum you can buy now, I think, is 4 cores, at least for a server-side CPU. So we've got clients that have upwards of 64 to 80 cores on their database server, and it's funny because the hardware cost might be $500,000, but that's nothing compared to SQL Server licensing. SQL Server licensing is very, very expensive, and Oracle is even more expensive. But $10,000 for a 2-core pack, for example, right? So if you've got 64 cores, you can do the math. But anyway, we use
when people say, "Oh, Microsoft, they give away Windows 10. How do they make money?" Like, you have no idea.
Right. Yeah, exactly.
They make money. They're very good at making money.
Yes, they are. So anyway, what I was going to say, we have to use database performance profiling tools. There are many of them out there. Our preference right now is SolarWinds DPA, Database Performance Analyzer. It just gives us so much insight into what all of our app servers using, all of our app servers are doing, exactly what SQL is being fired, what the wait times are, how long they take to execute. Are they, are the wait times memory, or are they asynchronous network I/O, which is a problem with multiple things? Is it disk pressure? Are the CPUs too slow? Are we, too few cores? Do we get tons of signal weights? All that kind of stuff, right? And one of the things that I've been working on and with Dev, of course, is to collect more information from the app servers. So, it's great to have insight into the database server and what it's doing, but wouldn't it be awesome to have the CPU pressure, memory pressure on every single core, on every single app server, where you have a broadcaster that has 30 virtual machines running 20 app servers each. And then you can imagine the data volume you get from that and your visualization issues after that, right? So how do you find the problems in that massive amount of data going from there?
Is that a tooling that you installed as a feature in the app server, or is that a tooling that runs outside the app server that does that for you?
So in this case, we added it to the product itself. So it's going to take time to get out there. You know, it's starting to get out there in the new releases. We got a couple clients running it, and so you know it's early. I'll get my first real test here on Tuesday. Actually, we have a big client that's upgrading over the weekend, so that's going to be very, very interesting. It's almost like waiting for a baby to be born to see what comes out of it.
Was there a library that you used, or was that code that was developed in house, or how is that tackled as far as the that functionality?
It's actually very little code. You know, it's just Windows API calls and runs on a timer thread to figure out what the CPU pressure is. It's very interesting. You can't ask Windows, you know, what's the current CPU load? There's no such thing. The CPU load, each core is either executing an instruction or it's not. So it's either 100% loaded or it's idle. So you actually have to get the timing information from the between two intervals, right? So you ask now and you ask a second later. How much percentage did the CPU or the core spend idle versus busy? And that's how you get your percentage. Even the task manager does that, right? So we basically we're measuring, counting that once a second and logging it maybe once every 2 minutes or something like that type thing and then of course if we ever see a problem we can change that frequency. But yeah, so getting CPU and memory pressure, and you know in our case we have built-in numbers too, right, that weren't surfaced in the past, current number of connections, that kind of thing as well. So we log like 20 different metrics once every couple minutes, and that's going to give us a lot of insight.
That's a really good idea. You log that into the database and then pull from the database. Is that how that works?
Those right now, those are actually logged as text files, as log files, because you can imagine how much data that becomes, and then it becomes a purge nightmare. Right, yeah. So you don't want to fill up your disks, you don't want to fill up SQL Server, all that kind of stuff, right? So in the case of the static information, you can collect that and put it in the database, right? So the one thing that we do is, okay, how much RAM do you have? How many cores do you have? What build of the OS are you running? And a couple of other things, right? What's your startup, disk size and startup disks, free disk space, that kind of stuff. Those are fixed values that get updated into the database once every 24 hours, because we have nightly restarts of the services and stuff like that. But when you have continuous telemetry, you have to be very careful of where that volume of data is going to go. It's on in text files that are just purged on a every couple of days type thing on a running trail or tail. Just to give you an example, one of our largest clients, has 30 app servers, and they spit out 30 megabytes of log files each every half hour. That becomes terabytes very, very quickly, right? So there's no way you're not purging that data.
Yeah. We have a similar problem. We have a customer that does time and attendance at a lot of grocery stores in the UK, like thousands. Mm-hmm. And people say, oh, we just want to record X or Y, some value. And of course, the amount of traffic that's coming in from these clocking in systems with thousands and thousands of employees, I have to do a little bit of math and show them that actually this will generate this much information, not something you can load into your spreadsheet and have a look at. So it's you're gonna have to aggregate it.
Yeah, and so that comes next, right? Aggregation or visualization of that massive data volume, and I learned a very valuable lesson back in college. We had VAX terminals and stuff like that, and I was doing some some algorithm, I forget what it was, but I introduced logging into a file, and I spun it off overnight. And I didn't realize it would flood the entire drives overnight, and the whole campus came to a standstill. And guess what? The next day they introduced quotas, disk quotas. So you can blame me for that at the school that I went to in Stockholm. But yeah, filling up disk drives is a very real problem that happens to the best of us all the time.
Yeah, there's a machine that has to reboot regularly because there are bugs in Windows and other Windows apps that they show up because they gradually, eat memory and things like that. There's no alternative. And there's so much traffic going through these different machines that normal people, non-programmers don't necessarily understand that concept that, there can be such a vast amount of information that's being processed in the background. Normal people like to think that, a task is easily quantifiable. Well, I can understand this, I'm not stupid. Think about it on a global scale where you've got hundreds of thousands of people clocking in and out, and they all start work at 8:30 in the morning. You've got a massive influx of data and then nothing happening for about an hour and a half, and then everybody goes to the tea break and the lunch break. And then these things, if you take them individually, one person at a time, it's not a problem. But if you start to then scale that up to 6,500 grocery stores across the UK, each employing up to 300 or 400 people minimum, it's a big scaling problem.
No, I see a lot of suggestions on, well, you should just stagger your workload. Well, I can't stagger my workload with this many clients and this many users. I can't tell the users to come in 5-minute shifts.
You'll have to change your working shifts. I'm afraid you'll have to close all these grocery stores at this time because you can't cope with the traffic. Yeah, that's not how the world works. It's our problem, not theirs. Yeah, I feel your pain. Not on the scale you do, but I've been there. It's a bizarre situation, really. That I think generally.
But then then you think of the scale that the scale only goes up from there, right? I mean, Google and Facebook, the scale you're talking about there is incredible. If you're do any work for those guys, I mean, the first thing that Google is going to ask you, okay, how does it scale? I mean, really scale. We're not talking about 2 cores.
Yeah.
There was a really interesting talk by one of the engineers at Netflix where they were talking about the content delivery network. And they use virtual machines. Basically, each customer gets a virtual machine that serves up the videos to them and things like that. And something went wrong. Someone made a mistake, and it just suddenly scaled up hundreds and hundreds of thousands of virtual machines, and they were running on Amazon.
There you go.
It's very expensive. Because Amazon can cope. Amazon goes, okay, you want 100,000 machines? Here you go. Here it is.
I attended a very interesting talk probably 10 years ago now. I got Netflix, and it wasn't about how when I watch a video or a movie or whatever, and I have my dedicated virtual machine. It was at that time they used virtual machines for simply ripping the videos. So if you take a 2-hour movie, you have a virtual machine that's preparing the content, and you prepare it for every single possible resolution that they can dynamically switch from, and that's how they avoid buffering. But all of a sudden your resolution goes up and down.
And now they use a continuously variable resolution as well, because if the traffic, it's very interesting. Their engineering problems are pretty spectacular. You think it would be straightforward, but of course it really isn't. Oh, you're watching on a mobile phone. Oh, well, I've got to scale it for which screen size? It's a mobile phone screen is not a unit of measure. It's a unit of one. But sometimes now they've got phones that do this. Have you seen this one that turns like that?
Yeah, there you go. Yeah.
Oh my word.
And Netflix, I can add to Netflix. They actually also do some pretty cool thing. They have cache boxes installed at each major core network provider, and they are constantly mapping out what movies are the most watched, and then being cached it at the core network. So, for instance, here in Denmark, they have a cache box. So there is actually a shorter path from you as the client to the content.
Yeah. Amazon talks about edge. I think what's the closest edge to you? No. Well, that's another entirely thing. We use AWS or other solutions for. We use a little bit of Google Compute Cloud and other cloud solutions as well. I mean, disaster recovery, for example, with SQL Server, it's important to have disaster recovery set up so that you mirror to a different region. And my DBA that works for me on my team, one of his favorite quotes is, if you have, are you sure you're taking backups? I mean, if you're taking backups and storing them on your local machine, that's not a backup. That's gonna catch fire or get wet when your server room is destroyed in a hurricane or a earthquake, whatever it is. You have to have that, copy that thing to your disaster recovery region, which could be on the opposite side of the world, right? Or in this case, West Coast versus East Coast in the US. And then you might want to have a third copy somewhere else, because otherwise you just have a copy. It's not a backup.
Well, it was just that data center didn't catch fire in
in France.
Yeah, that was terrible. Took out half their internet as well.
Yeah.
Half. And the backup machines were in the same place were not terribly useful because they burned out. So yeah.
Well, you might have read things about Texas froze a couple of weeks ago, right?
Oh, yeah.
There were incredible stories. There were incredible stories about very large companies that did not have disaster recovery because Texas never freezes.
Yeah, and I can tell you, I live in Dallas, and we were lucky. We had rolling power cuts for about 3 days, which was really irritating. You'd have half an hour of power, and then it would shut off for half an hour, but it was never quite that accurate. Sometimes it was 45 minutes, sometimes it was 2 hours. And of course, the UPSs everywhere had sold out. You couldn't get a UPS anywhere, and you could hear people with generators. All the smart people with the generators going, "Ha! I've got a generator." But then they'd run out of gas because all the gas stations couldn't open up because they'd run out of power as well. And of course, you go, "That's okay. I'll use my cell phone to get to the internet, right?" But of course, the cell phone towers, because the power was out so long, the backup generators on the cell phone towers ran out of fuel and they shut down as well. So there's no cell phone coverage either.
Yeah,
and
exactly.
everything just died. The whole, company and
there were entire data centers in Texas that had no backup generators, and it affected the state of California, for example, for I think it was Medicare. Their system was offline because there was no high availability option for them because, again, Texas doesn't freeze, Texas doesn't run out of fuel or power. all those things happen all at once because a lot of freezing.
Yeah, it was Armageddon, and people didn't know what to do driving on the snow. They're like, what do we do with this white stuff? I lived in Nebraska for 5 years. My wife, who was born in Nebraska, well, she grew up in Nebraska. She's like, "Oh, this is fine. I know what I'm doing." But all the other people who were born and bred in Texas, like, it's 5 inches of snow. I don't know what to do. I've just literally got to park and just stay in my house.
Yeah. No, I mean, I'm the
same
way,
the grocery store.
I grew up in Sweden. I learned how to drive in Sweden. There's, to get a license in Sweden, you have to basically be able to drive on a hockey rink. The worst part is actually when you have gravel under the left side of the tires and a hockey rink on the right side. So you have traction on one side but not the other. It's really fun, but I know how to drive in that stuff, but I don't trust anybody. I don't go driving in those situations because nobody else knows how to drive in.
Right. That's part of knowing how to driving is to know to avoid it. So
yeah, exactly.
All right. Well, thank you.
It goes to the other people. It goes to the other people that Ian wants to stay away from him, right?
Yeah, exactly. I have a whole list.
Thanks, Anders. I'm gonna move on here to Ian, and actually, I would like to have more conversation with you on that proactive stuff at some point in the future too. So
yeah.
Definitely. Yeah, I think that would be good subject.
All right,
My
so
subject.
Ian's up now talking to us about dating for software developers, which might
Yeah,
sound...
we don't show my slide. I had so many great jokes on there, and then the slide's not visible. But there you go.
I was going to say it's visible, isn't it?
Oh, is it? I can't. Maybe I'm seeing a screen that other people can't see. I don't know. Yeah.
No, I can see this slide on the screen.
Oh,
Yeah.
okay. Okay. Well, what am I looking at then? Maybe I have a different screen up. I have a screen where I can see all of this. You see, in Technicolor on the video. So that's what it is. I've got a different screen. So yes, I mean, this is my dating guide for software developers. See, I thought that would get a few people to subscribe via Twitter, because everybody is like a solitary computer programmer, right? I mean, really, it was provoked by a discussion where I think it was Dave Nottage, an MVP in Australia, who said, hey, there's a bug in Delphi. And what happened was he'd got a string come up, which was the month name, the short month name, and it had a period at the end of it, a full stop. And he said, hey, you know, Delphi's adding a full stop to the end of this month name, and it never had that before. You know, it used to be for June, J-U-N, and a space, and you could put the other days on. But then all of a sudden, you know, he had a period at the end of it. And it turned out to actually be that Java SDK that we were using in Delphi had changed. And Android has suddenly started using a different format for the format settings. And it made me think about dates in general. And by that, I mean, obviously, you know, days of the week and month and the year and things like that. Because I think Marco had some input on this as well. Do you know what I'm talking about, Marco, where we're saying the extra period on the end? Yeah, and what happens is that there's a lot of Delphi programmers that try and make the date time strings themselves using, you know, format date, and then they put some DD, MM, YY, and things like that. Well, as it happens, as obviously people know, I'm British, but I live in America, and the software I write is sold both in the UK and the US. And lots of places, people in the code that I worked on had assumed that the date and time format was going to be the format that they were used to. They were seeing it in front of them, so that they were not using the inbuilt operating system strings to format the dates and times. And of course, the biggest sin was putting 2 digits for the year. You know, did we learn nothing in the year 2000, where most of us, I was a contractor at that time too, I was a contract COBOL programmer, so I was very popular and in demand for taking all the 2-digit years and changing them in 1999 to be 4-digit years in COBOL programs. But people still seem to be using these kind of hard-coded strings to format dates. And so in Dave Nottage's case, he'd got I think the day or the week short format, put a comma after it. It's a simple thing. But now all of a sudden he had 3 letters, a period or a full stop, a comma, and it looked completely bizarre. And it's really down to not using the built-in functions correctly, I think, to format the strings. When I first started as a COBOL programmer, I worked for Dictaphone Company Limited, and they had actually turned up. They were originally, and I wrote this down, called Volta Labs, which then became Volta Graphophone, and then Columbia Graphophone. And they, if you remember these big wax cylinders where people would put a needle on the top and you would talk into these things, that was the original dictation machine invented by Alexander Graham Bell. And we had records in Dictaphone. We had a museum along the corridor there, and we had records that went back to 1888. So when we had property records, because they owned all sorts of bizarre property like St Pancras train station, you know, I don't know why Dictaphone owned it, but I think Rover did as well. You had to always format the years with 4 digits. So when the millennium change came along in 1999, 2000, there was nothing for us to do because we'd already been dealing with the previous millennium from the 1800s to 1900s. But I think that, you know, the one thing that I wanted to say is that how do people store their dates and how do they format them? What are they doing to retrieve these dates from a database and display them in a way that they think is going to be working in every. I mean, Glenn is Danish, right? Oh, correct. And
Yep.
Denmark, I have some software that's translated into Danish. Glenn, your country has the most bizarre date and time formats in the world, I contend. Is this true? You have like commas and slashes and all sorts of bizarre things.
Yeah, I mean, there is, you know, we have different ways of denoting our dates, you know, depending if it's short format or long format.
But it's not like anybody else. Am I right? And I'm saying that virtually, I mean, the only thing that you seem to have consistent is your official date format, because I looked it up, is 4 digits for the year, a period, 2 digits for the month, period, and then 2 digits for the day. So it's a kind of like a MySQL or a database format for the date and time. It makes a lot of logical sense if you think about it. But you have these localized settings where there's some commas and periods and things like that and slashes where nobody else in the world seems to have them. And also you have this other format where it's day, month, year. So anybody that's assuming that if they're American, it's month slash DD slash YY for the year, is going to stumble when they translate their software to Danish unless they've used some built-in format settings. You should always be using T format settings, comma, and then date separator character. And you go to code, it happens all the time. I go to this piece of code written by a Brit or written by an American. We go to try and test it out on the opposing country, America or the UK, and all of a sudden nothing works. I write a lot of time and attendance software and human resources software, so their dates of birth stored. And
I think that it's, I think it's important that you really, that's kind of you can have a like almost a unit test in your application that says, I'm assuming this comes in this way, right? And then you just test it, right? So if you're like, I'm using this date format. I had a thing once, I did a little program that was a timer. I was working in a call center when to keep track of how long you're on a call. And so at a timer, you tap and discovered that if it ran for more than an hour, all of a sudden it displayed differently because I was using the time format I was using to display it didn't migrate or didn't handle hours. It handled hours differently than I expected. And so having that tests in your program that say, I'm expecting it to behave this way, let me know when it doesn't.
Well, I'll tell you something interesting about that, and that is, you say unit tests, and I actually there is like a continuous build server that does unit tests as it goes along on certain things, because with time and attendance, there's a bunch of rules and laws that you have to. And of course, the unit tests do actually check the dates they're expecting and the dates that they've retrieved. But guess what? The person that set up the unit test put it on the build server, and the build server is configured for UK date format. So everything worked fine. But of course, your customer is in Denmark, where, as you know, as we've already established, they're crazy with the dates, or the US, where everything for a Brit is reversed. Your unit test that you've run on the build server pass, because you're not actually testing for the locale that you're going to target. And this is kind of one of these things where you say, you know what, actually, this is a little bit of a hole. I mean, it's okay to test the translations by giving it to a translator and say, I've translated all these strings into American English instead of British English, because, you know, there's a difference on some of the things, not necessarily the spelling of the words, because, you know, there's a difference there, but also the way that you use some of the words, like holiday for the UK and vacation for the United States. They're both spelt the same way, but they're actually used to mean different things. So if you do these unit tests to check your dates and check your localizations, you're gonna struggle to spot the problem unless you've taken into account there's a locale difference as well. So it just, you know, this whole, and then of course Android throws a spanner in the works by going, oh, by the way, we're just going to change the date format and we're not going to tell anybody. Here's a fix that we did, and it's right down in the kind of release notes that they started using CIDL or some, I don't know what it was, some kind of acronym. We started using a different way of retrieving dates and times, and it broke a number of apps.
And then you have multiple clients, you know, multiple users at the same client site that will have, one will have French locale, one will have Spanish locale, and Guess what? Last weekend, somebody upgraded SQL Server and changed it from US locale to something else locale on the SQL Server. Oops.
Yeah.
So what would you call tests that run in the application? I mean, that's you can do asserts in your application.
Well, that's more of an assertion, or in a way, it's a sanity check, because it's going to happen early enough before it's a problem. Because if you see, in a way, it's not as efficient as a unit test, because what you're doing is you're already running, and prior to there being a problem, you're trying to anticipate it in your actual code itself. So it's a more of a sanity check in your code. But it happens a lot, and some of these things are very difficult to spot, because if you're formatting a date to appear on the screen, that means you've actually got to check what that result is before you display it. And if that's a control that's linked to a data set, let's say live bindings or something like that, and you've applied a formatting in the control rather than in the code, you've got to actually retrieve the value that's being displayed from that data-bound control or however it's being retrieved, intervene in between there and say, is this actually what I want? Most times, when it's just a display value, it's inconvenient. You know, a customer's annoyed, except when the month is less than, the day is less than 12. Because, of course, the 5th of the 12th to a British person means the 5th of December. The 5th of the 12th means the 12th of May to an American. And I'm sure to a Danish person, or to maybe, you know, Portugal or somewhere like that, it means something else as well. And it's one of these things where it's a tiny little thing to worry about, but actually it's more significant than it appears. And once you start to scratch the surface of how to prevent this problem from occurring, where you display something horrible on a report and confuse everybody by them saying, well, wait a minute, his date of birth was the 12th of May. Why are we going to, you know, give him an annual pay rise on his birthday if it's not arrived at the 12th of May yet? But actually, you've got it the wrong way around, because someone has stored some value in the database and not used a date format or something like that. And of course, then you get the likes of Postgres SQL, which is completely insane because it has a timestamp. Are you familiar with Postgres SQL?
Didn't know how it started date. I'm familiar with the database though.
Yeah, they have a timestamp format which is got two variants. One of them is timestamp without, I forget what their wording is, I did note it down, without locale, and the other one is a timestamp format with a locale. What it does is it stores the value internally in the database as a Zulu time. So, you know, equivalent to GMT, I suppose, or something like that.
Mm-hmm.
But it then includes an offset. So when you store that data in the database and you're on a British machine that's running in British summertime, or an American machine that's running in daylight savings time, it stores the offset from Zulu time, which is GMT, or UTC, I suppose is another way of looking at it. I kind of see why they're doing that, and it is useful because if you've got someone who is working a shift overnight, this is a specific problem, I suppose, for time and attendance, but you want to record that something started at a particular time and ended at a particular time, and it happens to cross a midnight boundary. If that happens during the clock change, and you're not careful about what you're doing, all of a sudden that person has either worked or that event has taken an hour longer or an hour less than it should do because of the clock change. So it's one of those things where, you know, again, date and times, they're simple, right? There's a T-date time and it's easy to use, but there's an awful lot more that goes on behind the scenes that you need to consider about how you format it, how you display it, how you localize it. Don't use hard-coded strings like commas and things like that unless you're absolutely certain that you've filtered that T-format settings month for those characters and take them out. And of course, if you start changing the format string by removing commas and periods and full stops and things like that, someone like Glenn will look at a Danish time and go, this makes no sense. Where's the full stop that I'm expecting in the middle of the time or the date or something like that? And
daylight savings is very interesting for broadcasters because once a year you have two 2 a.m. hours, and once a year you have no 2 a.m. hour.
Yeah.
I remember I was working at WideOrbit. You have AM, PM, XM, YM, and ZM for scheduling too, which was like, what in the world is this?
Yeah,
So,
well, with time and attendance, you get people say, "Oh, I'll pay this guy some overtime once he's done more than 8 hours," or this girl, or whoever. Which is great, but of course, if they are working on a shift where the clock goes forward, all of a sudden they've done an hour's overtime. So we have to take account of that and actually say, what was the time when we started, and make a comparison to what that time was when we first started monitoring it versus what the server now thinks it is. Because the other thing people do is they try and defraud their employers by changing their computer times and stuff like that. Now, we take our time from a time server, which prevents that, but even so, you still get people who know how to edit host files and fake the UTC and stuff. If there's a type of time fraud, I've seen it happen. I've seen one company where a bunch of people, they defrauded the company. What the guy did was they worked a night shift. He said, "Hey, you know what? You guys go home. I'll take your swipe cards and I'll clock you out, and you get paid the time. But you can all go home early." And everybody went, "Right, great." They got caught on the CCTV going home. But what he did then was he let in his people, and they robbed the warehouse. He was a plant, and they stole. It was a bond store, sales tax or VAT in the UK. We were then asked to come in as witnesses to prove that this guy had actually clocked everybody out. And the mistake he made was he went up to the machine and went, swipe the card. So this was 8 years ago when people still use, most people now use fingerprints or facial recognition or hand scanners, but he swiped the cards one after another. And I could prove statistically that, first of all, that was not how normal people do it, because it takes a few seconds for someone to go in front of the machine, and people clock in and out on quite a predictable basis. But secondly, we could prove who the one was who was the genuine person. People have every way of stealing time. I've seen it.
No, I actually have a funny story about time and Delphi applications. So I was once in a small country where they use Delphi for some like admin and they have a lot of public employees there, and so I was in a conversation and said, yeah, we've deployed this application, but the problem is that we created a Delphi application that caused traffic jams. What? How comes a Delphi application is causing a traffic jam? Well, you know what? Because people used to like show up at work when they want to show up. So we deployed this Delphi application that they have to like check in and check out. And so everyone had to like show up at work at the same time. And it was like a large organization. So everyone showing up at work at time caused traffic jams that were not present before, when people just show up when they wanted.
This is a problem for us as well. I mean, people say, oh, they only want to buy one hand scanner, because a lot of the places, where you have to wear gloves to handle food and things like that, they get them to clock in. The platen of the hand scanner is antimicrobial, and they put the hand on. But it takes a certain time for the hand scanner to scan the hand. And these guys all want to turn up, and they're not allowed to work overtime, but they have to turn up on time. It's stupid. And I say to people, you need either more hand scanners or you need to give them 5 minutes to clock in. Because if there's 20 people turn up for a shift, it's going to take X amount of seconds for people to clock in.
I had time
with GPS system. One's GPS time, which is 17 seconds, I think, currently behind UTC. And I had two radio transmitters, both using GPS, but one picked up the UTC time and one the GPS. And I wonder why they were transmitting 17 seconds offset from when they should be. It took some chasing.
I read that they have to take advantage of something to do with losing time because of relativity, the theory of relativity.
Yeah.
I didn't know this was a real thing. I'm like, what? You mean those clocks are actually older than we are, or the other way around? It's very bizarre.
There's
time travel exists.
There's a speed-based difference because of the satellites orbiting, and then there's gravitational dilation. So the time up there is running slightly faster, isn't it? I can't remember, than time on the ground. So the GPS satellite's correct for one of them, and your satellite receiver correct for the other one.
That's the kind of thing that makes me want to be a cook.
You don't have to think about it, though. The GPSs have done that for decades.
Good.
Yeah,
you as an end user don't have to worry about it.
Good. That's the way I like it. Somebody else's problem. That's perfect for me. Yeah.
Yeah.
They didn't correct for that. Your GPS location would be out by kilometers every, I think it's several kilometers a day.
The early ones used to be very inaccurate, and I understood that this was like a deliberate error that was introduced originally because they were worried that someone would use it for targeting weapons. And they're still not as accurate as the military ones, I understand as well. But nowadays,
the consumer ones were accurate to 10 meters 25 years ago, but you bet the military had the centimeter ones.
Yeah, yeah. And now they probably geolocate on Wi-Fi.
You have to translate that to feet and inches if you want to.
Yeah.
You can do differential GPS if you know where a fixed position is.
Yep.
Use that as a reference, so that then adjusts something that moves relative to that fixed position. And you can get centimeter accuracy with that.
Yeah, it's very interesting stuff.
Actually, I was just going to say we need to move on to introduce Dave. So Dave is here. Talk to us
before doing that, I need to stop and talk a couple of other things coming up. So thanks a lot for the chat and conversations, and talk to you soon. Bye-bye.
Thanks, Marco.
Bye, Marco.
And I have to leave as well. It's been a lot of fun, but I have to take my daughter to a dentist. So we'll catch you next time.
Okay, bye-bye.
Thanks, Anders.
Yeah.
Bye. I remember Dave or Anders and Marco said they need to leave early, and I'd forgotten about that. So sorry about that. So Dave, you wanted to talk to us about you're using Delphi for work and play, and I have a few pictures from you here. Maybe you want to walk us through what we're looking at here on the screen.
Yeah. And so I just ask you to step on each picture?
Yeah, and I can click it. Yep.
Yeah. So the reason I'm on is I watched the Perseverance rover, which you wouldn't think that has much to do with this picture in front of you, but it does. And I watched that on TV, and then I think the next day someone tweeted, that parachute was made in Devon. So, that's interesting, because parachutes made of textile. There aren't many textile manufacturers in Devon, and one of them is my customer. So I was idly thinking, that's nice for them. I wonder who it is, and I checked, and it's my customer. Oh, that's good. And then slowly my brain started ticking a bit. I said, if that was manufactured there, then it's my software that actually helped make the fabric. So the picture you see here on the left is a machine called a stenter. So this takes fabric in at one end, then it processes it. It will heat it up, cool it down, apply chemicals, apply dye, that kind of thing. These normally they have about half a mile of fabric going up and down, left and right, round in circles from one end to the other. And on that picture on the left, you can see the fabric going in white, and then it's coming out dyed with yellow. I don't directly have anything to do with that machine, but what I do is I write software which mixes the colors. So in this application, it's mixing the dye stuff that you can see on the right. So that orangey liquid, when it's applied to the fabric, looks yellow. So the color in there is made up from a recipe. So there will be different colors and other chemicals, additives mixed together. And the software then takes a recipe, just like cooking something, and mixes those together using valves, pumps, and usually weighing scale, but sometimes it's done by volume. This one's done by weight. You want to click on to the next image? So this is the machine at that factory where the fabric was made. And on the left, you've just got supply vessels. And on the right is a machine which was made by some company before I got involved. That company stopped existing, and they got in contact with me to supply software because they had no support. So what you see there is just a weighing vessel. It's got load cells, so it knows how much it weighs. All the chemicals just get pumped into the top, and there's just valves opening and closing to get the right color. This software is actually used not just for textile dyeing, it's used for leather, for packaging, paint, all sorts of things. Next slide. So on the left, that's a panel PC. It's just running, I think it's the older one that's running Windows 7. They're running Windows 10 now. And that's just a little touch screen where the operator of that Stentor machine comes along, requests whatever color mix it is he's running at the time. And the picture on the right is just a wider view of that machine. And they have several of machines in that factory, all of which are fed from that one dispensing machine. Click next, please.
Okay.
So on the left is what it used to be before I got involved, and on the right is what it was afterwards. So I tried to make the user interface operate very similar way to the old one, so that the operators wouldn't have too much of a shock, but just prettify it a bit. That application just does the mimic diagram and allows the operator to request dispenses, and there's a separate application which does all of the pumping, valve control and everything else. So they kept separate. One advantage, these two programs chat via TCP/IP. So that application you see on the right can be put on different PCs around the factory, and different people can see what's going on. Meanwhile, the machine itself is busy in the background, keeping everything running. So next, please. Right, okay, that's quite quick. So that program on the left, that's what keeps me keeps the finances going. When I'm not busy doing that, my hobby is flying weather balloons. So I got involved with this 10 years ago this year, when I saw a video of someone flying a weather balloon with an iPhone for tracking. The problem with running an iPhone for tracking is if it lands outside cell phone coverage, you've just lost an iPhone. So what everyone who does this seriously uses is a radio system. So on that picture there, you see a balloon, has a little tracker on there, which has got GPS and a radio, and that sends a signal down to the ground. And on the ground, you have a ham radio typically, and a laptop or PC, which receives the signal, decodes it, sends it to some servers, which we share amongst all of the ballooning community. And then your balloon appears on the map. So there's and that's a Google map, so you can watch it in a browser. There's a car there as well, because we have software running in the car which tells the same map where you are as when you're chasing the balloon. So all the other, we have a community of people doing this, and everyone can see where you're chasing the balloon, where you are. Next slide, please.
Oh, it's like Star Wars, Star Trek.
Yeah, exactly, LCARS. So the previous diagram, that all existed before I got involved. But the problem I felt at the time was when you're chasing a balloon, you don't really want to be carrying a laptop and a radio ham receiver and a big aerial across a field. Typically, when these things land, they're about 1 kilometer away from the road. You'll get a signal from it when it lands, and you'll know where it is, so long as no one's picked it up and taken it away. So ideally, you need to take the receiving and decoding equipment with you. I've had balloons land on a golf course, and we watched the thing as it was being led around from hole to hole because someone spotted it, picked it up, tied it to their caddy, and just took it around. So you need to know where the thing is live. The video for that's quite fun after. I thought it'd be nice to get this a bit smaller. Since I started 10 years ago, radio technology has improved, and nowadays you can get tiny little, let's try to get one here if this looks on here. So this is like a $20, $30 board. That's a GPS at the end, and the next bit's a radio transceiver, and that does all the decoding for you. So you can have one of these things, it's got Bluetooth as well, one of these things linked to a mobile phone or a tablet, and that will tell you where the balloon is. So and that's easy to carry. So you just have one of those in your pocket, and then have a tablet connected. So this is a LCARS, which is from Star Trek, New Generation. This is an application I wrote which knows where you are, because your phone or your tablet knows where you are, and it knows where the balloon is, and it can tell you it's 100 meters ahead. that application does online mapping as well. So you can switch to, you can just press a couple of buttons and it'll give you driving directions to the payload. You click a couple more buttons and it'll tell you where the payload is in a field with kind of ordnance survey mapping, which is like off-road type walking mapping, so you can get there efficiently. It's so much easier to chase balloons now with this sort of technology than it used to be before.
How is the signal transmitted from the balloon to the mobile?
Right, so this here could be a tracker or receiver, so that, because it's a radio transceiver, it does both.
I think people can only see the slides at the moment, not necessarily what.
Oh, okay.
There we go. I'll make it bigger. There you go. You can show it up on the screen.
There you are. Okay. So you can buy these trackers. This one is it's an ESP32 processor, and it's got a GPS and a radio and a battery. You just connect an aerial to that, attach that to a balloon, and that will transmit a radio signal with telemetry containing the GPS location of the balloon. So longitude, latitude, and altitude.
And then you have another one of those boards in your pocket that receives the signal and sends it to the Bluetooth.
You have another board in your pocket with another aerial. The manufacturer of these things, they'll say, oh, the range of that is 1 kilometer. Yeah, because when you're on the ground and you've got buildings and trees between you and between the transmitter and the receiver, you may have 1 mile. But when that's in the air, there's nothing between you and the balloon. So it's line of sight. And the range could be 4, 5, 6, 800 kilometers. And that's where the radio power of 10 milliwatts, which is about the same as an LED. So it's quite staggering that it works. But it works really well. And the clever thing about that distributed system I showed earlier is it doesn't matter when you're chasing a balloon if you know where the balloon is, so long as someone does. Because if someone's received the signal and uploaded it to the servers, then the position of the balloon is updated on the map.
So Lars is asking if you can provide a link or details on where someone might find that tracker that you were just showing. Is that there a model name or something like that for it?
And that one is it's a TTGo T-Beam, T-Beam.
Go T-Beam?
Yeah, T-B-E-A-M.
I was actually just looking at some TTGo stuff the other day.
They've got a lot of interesting stuff.
All right, I found a link for it here. It's got LoRa in it, so yeah, okay. Okay.
Exactly. I didn't say, but that's a LoRa radio transceiver. So LoRa stands for long range.
Interesting.
Yeah.
I actually just recently started playing with software-defined radio as well, and so I'm interested. Just looking at things now, it's like, oh, I can see the frequencies this transmits at, so I can look into that, and thinking about how radio transmissions work and go and such.
People do use the software-defined radios because they're very cheap, like $20, $30 for decoding balloon transmissions. But unfortunately, LoRa's it's not published format, so I think someone reverse engineered part of the encoding, but it's not complete. But these things are so cheap, you just can buy one.
Cool.
Yeah, next slide. Okay, right. So having applied Delphi to for the kind of chasing the balloon Android application, which is iOS as well, by the way. I was amazed how easy it was to build for iOS as well, with the same source. Yeah, 99% of it anyway. So I then wrote I had a flight for I think it's the 50th anniversary of the Apollo moon landing. I was about 9 or 10 years old, so that's affected me. That's all my life. Anyway, so I thought I'd repeat it, and I made that a picture of an airfix model of the Apollo spacecraft. And I thought it'd be cool to have a dashboard that looked like the old Apollo mission control screens. They never had a graphic like that, but I basically took a photograph of one of the mission control screens and made a web dashboard. This is using TMS Web Core. So the top part of that is the telemetry from the balloon. And then the bottom is a live image we downloaded during the flight. People watching on the web actually saw that image.
That is very cool.
I can't chasing it, but
I like that. Very cool.
It's very cool. There's if you go to my blog, I've got a video as well. We had a GoPro on the flight, taking basically that same image, and that's a lot of fun, especially when flat earthers come along and say, "Oh, you faked it." Yes, it is a model. I'm not pretending I'm NASA. that's an extra plus point of flying weather balloons. You get nutters. Yeah, next one.
That's it. Yeah, that's it for your slides.
Cool. Oh, okay. Yeah, questions.
So this is a picture here of the user interface you built in TMS Web Core. Is that what you said?
Yeah, exactly. See, that was a live interface. So the image was filled in as it was received from the balloon, and the that orange button and the kind of beige buttons next to it, people can click on those. Oh, and just for added fun, when you click on them, as the screen changes, it does a kind of like the old VHF black and white TVs used to have a kind of the scan used to lose lock. It did that, and it did the is it quintar tones that used to be on the audio with the astronauts to synchronize between transmitting and receiving. So when you click the buttons, you get all those effects. Because
cool.
Once you start down this road, you just have to keep going, really.
It
awesome.
goes back to the story of feature creep again.
Yeah. Well, I was inventing the features. So, and some of the things that were like, that image is in black and white. Obviously, I had a color camera, but it was converted to black and white at the tracker. I had live video from the launch site, which is my garden, and that was in black and white as well. I had Google Maps in black and white, which is quite easy with a bit of CSS. And that where it says 3D, that's I think called cesium, which is something like like Google Earth that you can embed in an application, either a regular application or a web application, and it gives you a 3D view of the planet from wherever you tell it the camera is. So that was set from the telemetry. So basically, it flew a virtual flight throughout that people could watch, and again in grayscale, just to keep that kind of 1960s vibe.
You know, all great software is like a good any other piece of art. It's never finished. You just merely abandon it. And I could see how there would be more and more things you could do with this. It's amazing. What a great project.
Well,
really
I had to stop because I had to fly on the 50th anniversary.
That's what they call a hard deadline, isn't it? Yeah.
That's a hard deadline. Actually, I gave myself a gap because they're in space for a few days. And the other thing is you need the weather to be right. So I think it was launch day I launched on rather than moon landing day. But I had 5 days, I think it was, to choose from. But that hobby is very dependent on weather. If it's too windy, then you can't launch. And also, if the wind pattern means it lands near a motorway or in the sea or near a city, then you shouldn't launch either. So. But it was a lot of fun.
That is really cool. And actually, I shared the link to your blog in the chat, and when I clicked down on your blog, and I could see there's a lot of cool stuff on here. So
yeah,
cool.
I'm at a stage in my life where real work is kind of tailing off towards retirement, and I just do this stuff instead. Especially since COVID, probably 80% of my time has been doing ballooning.
I always said if I won the lottery, I would still program. I would just do different stuff.
Yeah. I think when you work for yourself doing something interesting, what's retirement actually mean anymore? It's you just if you haven't got work, you just do something that you want to do, and that's a bit more fun maybe.
I try to do both. Something I want to do, which someone will pay me to do. but yeah, I totally agree.
I got one which someone mentioned earlier about Delphi being their kind of, spider power, or some correct like that.
Superpower, that'd be me. Yes.
Yeah. So I had a friend of a friend worked at a place, and they were working on A1GP, which is like Formula One, but one or two rungs down. This was a few years ago, and that company had telemetry from the cars to the pits, so the people in the pits would know where the car is on the track, fuel levels, lots of, I think about 100 different values in the telemetry, and but they'd also been contracted to supply this information to the TV. So if you watch Formula One, you'll see the G-forces and the steering lock and all this stuff. And there was a company doing the on-screen graphics, but there was no one connecting the two together. So I had the call, and it was 6 weeks before the first race. And Dave, can you do this thing? So I had a chat and gave them a quote, and they said, "Oh, what are you going to write it in?" I would, "Well, Delphi, that's what I do." "Oh, can you write it in C++? I said, "Yes, but the race is in 6 weeks, and you're not going to have it in time." So, so they kind of had no choice. But that was quite cool. So the first thing I wanted or needed was 22 race cars to test with, because you need to do some testing with a lot of data. And this is 22 race cars, each transmitting 10 times per second times 100 readings. So there's quite a lot. Plus they had two receivers each end of the track, so that's double that lot. So I wrote a program to pretend to be a race car times 22 times 2, and tested with that. So when I went to Silverstone Racetrack, first day testing, I wasn't concerned at all whether it coped with the data throughput, because I'd already tested that stuff. Then the first race was at Brands Hatch, and they did a sprint race and then the main race with 1 hour in between. And the telemetry had checksum on there, so you could tell whether there's a good packet or a bad packet. And I've been asked to code this for just an 8-bit checksum, which means if you've got a bad packet, you've got a 1 in 256 chance of not noticing. And sure enough, they were getting too many errors. So the on-screen graphics, I saw it, I was watching on TV, and go gear 1, 2, 3, 1, 6. No, that's wrong. Doing that. So, and I think it was about 5 seconds after the end of the first race, my phone rang, and I knew what this was going to be. "Dave, can we have a 16-bit checksum now?" before the second race. So they already had a guy running around the pits to 22 cars, changing a setting in the firmware to do that switch. And then I had to rebuild the program, do a quick test with my emulation, email it to them, and it ran on the second race.
That's impressive.
Long ago, I was working at a PC company, and I built software that was installed on all the PCs. And frequently, they would come and say, "Hey, we need a new feature. Can you add this for engineering test?" And I was like, "Oh yeah, sure, no problem." And I put it in right away and get it over to them. One of the other guys I was using Delphi, and one of the other guys that wasn't using Delphi, he's like, he said, "You're making this look bad. You got to do what Mr. Scott does. Anytime someone asks you for an estimate on getting something done, say it's at least a week, and that's if we were in space dock." And I'll see what I can do. So that was my standard answer after that every time. So I was like, "Can we get this feature added?" Or I was like, take at least a week, and that's if we're in space dock. But,
the engines cannot take it, Captain.
Wow, that's very cool. So is some of the software you write up on your website here, Dave, or is there someplace we can find it?
Yeah, I don't talk about Delphi so much because the people I think read my blog are people flying balloons. But yeah, the applications, I've got an application for Android tablets, and a slightly cut down one for Android phones. So that's all on my blog, yeah. And it's all free. I don't charge for any of that stuff.
So is that under receivers? Is that where I'd find the?
Oh gosh, I can do a few interesting links afterwards, maybe. But,
all right, if you want to put those in the chat, that'd be great. And then I'm gonna go ahead and talk to Glenn really quick while you add some links to the chat. This is really interesting. I'm gonna be checking it out some more. It's something I just recently started playing with more. So
who knew we would have more than 2 hours worth to talk about?
All right, Glenn's, we're talking about the benefits of FreeBSD jails, ZFS snapshots, and Delphi.
Yep. You know, the thing is that I like to tinker a lot and think out of the box. And that also includes working with different operating systems besides Windows and Linux and Mac OS and the more common operating systems. And one of the operating systems I really enjoy working with is in fact FreeBSD. And as some might know, the kernel in Mac OS, the Darwin X-New kernel, is actually based on an old fork of FreeBSD back in version 3 or something. And Netflix, WhatsApp, Sony uses FreeBSD in their PlayStation 4 and 5. So FreeBSD is actually in many places, and it's a very solid operating system. And what I've been doing here with some research is that recently, with the jails feature in FreeBSD, which is kind of similar to Docker, what you can kind of like compart your dependencies in a secure manner, and you can log it off, kind of like you do with Docker. But jails actually predates Docker. Jails appeared back in FreeBSD 4.0, which was released in March 2000. So jails has been around for a very long time, and it's very rock solid. And when you look at the technology, it's actually how you wish Docker would have been engineered. But the cool thing here about the jails feature is that with FreeBSD 12.2 release, they added full support for running a Linux subsystem within a jail. And that means when you have applications that is tailor-made for Linux, you suddenly have a possibility to run these applications on FreeBSD. And that also includes using the features that are in the CFS file system, like snapshotting and replication for added data security, and also moving around for moving the jails to different hosts. And what I've been working here is actually using the Linux compiler which comes with Delphi to build applications that run inside this jail. And that means you suddenly have a very lightweight and secure way to publish your applications. And what I'm very interested in testing out, I haven't got around to testing it yet, but that is actually installing interface inside a jail. And that means if I can get interface to run and it runs very stable, you could potentially also host a RAT server inside a FreeBSD jail. So, you know, that's actually a very interesting feature. And some would also say, but why FreeBSD when we have Linux? It also boils down to that FreeBSD has a more lax license. So that means if you're developing a commercial project, you have much more freedom when you're developing your project. Whereas when you're working with Linux, there is some licensing you need to be aware of how you're using it and so forth to stay in compliance.
FreeBSD also has a significant advantage, I think, in that because of the provenance of where it came from and the ethos behind it, it is actually empty of any additional junk. You know, it's basically, it's the operating system. It's designed to be the operating system. It's not designed to be a replacement for Windows, which is, with respect, what Ubuntu is, for example. And Ubuntu has an awful lot of, you know, stuff that Canonical have added, but Some people don't like it, and FreeBSD doesn't have that kind of nonsense going on. And I think that's why it's popular for people hosting.
Yes,
you know.
Exactly, and it is very rock solid. It's not a long time ago I saw a tweet from a guy that was like, I really don't want to reboot my FreeBSD server, but it's been turned on for over 15 years. No, actually over 15 years.
Oh.
And the only reason why it died, I think, was actually because of a hard drive failure or something.
Isn't it Richard Stallman that was behind FreeBSD originally, or if I misunderstood?
He was
no.
Linux. GNU is his.
Yeah, not Linux, GNU/Linux. He says it all the time. Yeah, I should remember that. Yeah, don't call it Linux, call it GNU/Linux.
Yeah.
Interesting guy.
And actually a little interesting note here that Jails was actually written by a Danish developer, PHK or Paul Henning Kamp, same guy that also wrote an MD5 implementation. And if some of you have come across this Varnish web cache and it says a Guru meditation error on a website, he's the same guy that also came up with the Varnish cache.
Yeah, a few years back, I had a weird situation where we were writing some software and translating it into Danish. And this was probably 2000 and something, very early on. And we went over to Copenhagen. And the guys there, I won't say their company name because I don't know what the situation is with them nowadays, but we were the guests and they took us around. And long story short, they owned a vodka bar as well as a software business. It was a very strange combination of, wasn't that strange for Danes, but but really like Copenhagen. But they said, hey, do you want to go to the University of Copenhagen because we're responsible for all the networking in there, and it's one of the things their business did. I said, yeah, sure, why not? Let's go and have a look. They went to the University of Copenhagen and they did all the security locks as well as everything else, in the background. So swipe cards and push buttons and things like that. And he goes up to this, apart from showing us a Cray, which was just sitting in the University of Copenhagen, completely powered off, and you could stick your head inside the Cray, which was quite incredible. But he said, "Oh, come to me, I'll show you this room." And we go to what looks like a closet, a wardrobe where you would hang your clothes. And he opens the security and he's got the right tag and everything. He opens up and there's these shelves, just wooden type shelves with a bunch of computers on, various, look like Amstrad PCs and early IBM PCs and a few towers and things like that. Just a closet with a lot of wires on it. And I said, oh, yeah, that's cool. He said, this is .dk. And that was at that time, that was the Danish internet.
Yeah, that was
and it was running from the Copenhagen University. I mean, obviously nowadays, I'm sure it's in some big data center, but yeah, Denmark is a very interesting place.
They're actually still hosting one of the root DNS nodes, the Danish Technical University, DTU.
Well, Copenhagen Hospital, they had a human resources system entirely written in Delphi. I know because I wrote it, and it was translated into Danish. So it's a big organization. I'm sure they've moved on now because they've never had any updates for years, but interesting stuff.
So,
do you have Glenn, do you have a blog post, or I'm actually really interested in this, where I could go out and learn, get started with this?
There is, I'm almost finished writing a blog post on this, but so everyone can tinker and test it out. And I would also like to add here that for the gel management part, one challenge that has been, for the adoption of gels and also why Docker has become more popular was this whole orchestration system that is behind Docker, like Kubernetes and Docker Swarm. But actually, I just today I saw a guy who has worked at Gel Manager, which is this Open Container Initiative compliant. And very short, the Open Container Initiative is a standard established to how to manage and scale and deploy containerization on a large scale. So I'm really sure about this will take off once this get more developed.
Yeah,
very cool.
Very cool.
Lots
Excellent.
of interesting
All right.
stuff.
Well, I think that's it for this session of TCoffeeAndCode. Oh, I gotta go back. I'll bring this back up again. Thank you, everybody, for joining us, for panelists, and I'll try and figure out how to improve this for next time. We clearly had more stuff to talk about than we had time today, but if maybe if one of you have things you want to talk about more next time, we can revisit this in more detail, for example. But thank you.
We're going to have a replay as well, aren't we?
Yes, the replay will be posted on YouTube and up on the blogs.embarcadero. If you just go there and go to my name, you can. I'll have a replay link up here shortly for this. So, all right. Well, thank you, and I'll talk to you all later. Good luck. Take care.
Bye-bye, everybody.
Bye.
Bye.